On this next phase shift graph, I've given myself two problems. One, I'm doing the cosecant, which is a little bit tricky, but not too tricky. And I've also didn't have some multiple of pi there. I've got 1 radian, minus 1 radian. What that means is that this whole graph has moved 1 radian to the right. And the way I handle that is this. I go out here and I establish my scale by putting 2 pi. Okay? Because we know one thing, we're not going to graph the cosecant initially. Excuse me. We're not going to graph the cosecant initially. We're going to graph the sine of x minus 1 and dotted line, and then we're going to be able to get the cosecant. So I'm really thinking in my head, well, I'm going to graph y equals the sine of x minus 1. Okay, that's what I'm really thinking. So I know it's one period is 2 pi, both the sine and the cosecant. So I go out here and I establish my scale. Once I do that, if you think of pi as merely being 3, then this is 6, isn't it? This is 3, and this is about 1. So this is 1 radian, about that far, and we're moving this thing to the right. So I'm going to put 1 radian here, 1. And that establishes, right? And I'm going to put my fake y-axis here just to show that I've moved it, right, over to the right 1 unit. Remember, this is not a vertical asymptote because this thing goes right through it. It's going to go right through it, but this is where it starts, okay? So this distance I'm going to go over here, and I'm going to have to extend this out a little bit. And remember how I got this? I considered this 6 radians. Actually, it's a little more, but roughly 6 radians. So I figured this is 3 radians, and about 1/3 is about right there. And if you do this on your calculator, you find this actually is pretty accurate. Now, how am I going to get this increment? Well, this is just 2 pi plus 1 radian. That's all. We can't add. There's nothing you can do. You have to just do it that way. I'm going to, in my mind, get the midpoint here. And this, of course, would be pi plus 1. And then these would be divided into 2 parts, right? And I'm not really interested. Oh, what is this? This is 1, isn't it? You can see that that's 1 radian. Here's pi plus 1 radian, 2 pi plus 1 radian. And now we graph the sine, right? That's all I do. I pretend this is my distance here, and I'm going to graph the sine. Of course, it's 0 here. I go up here. This second increment is here, and then this is here. And then I go down right here. And I want to make sure I don't go too far. And now there's my dog barking. You can hear her do that. And I've missed one, haven't I? Oh, this one. I go down to -1 right here. I'm sorry. And then I go up to finally here. It ends up there. Of course, that's to end up on 0, right? And it looks like that. And I made another little mistake. I should have done this in dotted line, right? Because this doesn't count, right? This is a dotted line graph. We're graphing the cosecant. And I always graph in dotted line. This is pi plus 1. My dog disturbed me there. There we are. And so that's just dotted line graph. Now I know wherever this thing hits the x-axis here that you're going to have a vertical. Well, it turns out we do have a vertical asymptote there. Although I said it wasn't one, it turns out to be one, right? So not for the sine it doesn't, but I'll get rid of the y hat because this actually is a vertical asymptote. And you get your cosecant by doing this. And then like this. And you have to remember that this continues on. Now, the nice thing about this, it's very clear that I've got a cosecant here. And I started at 1 radian, went to 2 pi plus 1 radian, and it's very clear that this has to be the cosecant of x plus 1. And make that nicer, x plus 1. So that's how you handle when you don't have like multiples of pi radians.